Okay, folks, this is going to be a quick video on some material properties: strength, hardness, toughness, elasticity, and ductility. And as the video is in another language, what I'm going to do is just do a quick translation of it and just go over some of these properties. Now, mechanical properties are those properties of material that define its behavior when a force is applied. And the reason why we're doing this is because when we're looking at the chapter in engineering products, where we're dealing with engineering materials, modification of materials, etc. Just after we looked at heat treatment, they started talking about application of materials. And one of the, there's basically three things that are considered: the suitability of the material, the availability, and how hard it is to process. So this is down to material suitability, because obviously how the material behaves is going to be a huge determining factor on whether you actually use it. So the first one is strength. And strength, it's very hard to sometimes think of the difference between, say, strength and toughness. And so strength is the ability or capacity of a material to withstand or support a load without fracture. So basically, think of a steel girder or a beam made out of timber, and we're hanging a weight off it, a load. And the more load it can carry, the higher the strength of the material. So that's your strength. If we go further through this video, we come up against another definition, and that definition is hardness. Now, hardness is the ability of a material to resist scratching or abrasion, penetration or wear on. So the ability of a material to resist those things, abrasion and wear, is known as hardness. Okay, so they usually test that. They used to test it on what's known as a Mohs scale from 0 to 1, 0 being, I think, talc, and 0 to 10, and 10 being diamond. Now there's a lot of different tests that are used to determine hardness, and later on in the course we'll look at those things more in depth. But just remember, it's basically the resistance to scratching. So strength is the ability to hold the load. Hardness is the ability to withstand scratching. Okay, so obviously if you were going to have a screen for a touch screen, you don't want it to be scratched while it's in your pocket by your keys or your finger to wear away the surface, so you need a very hard surface. You might also need toughness as well, which is the next thing we're talking about. And alkali aluminosilicate glass, otherwise known as Gorilla Glass, is a good example of something that's tough and hard. And toughness is the ability of a material to withstand a shock, loading, or impact before it fractures. Okay, so this is a test that normally we actually looked at it when we were looking at our video of hardening of steel, and they did a heat and a quench, a heat treatment on some steel, and then that created martensite steel. And then they also took that martensite steel and they performed the process on it known as tempering. So we tempered our martensite steel, and when we tempered our martensite steel, we tested the untempered and the tempered. The tempered martensite steel was a lot tougher. Okay, so it was able to absorb an impact. Okay. So, and there's various tests for that as well. So that's our toughness. We go on to elasticity. The ability of a material to regain its original shape and size after the removal of an external load is known as elasticity. And we think of an elastic, obviously, that can spring back, but actually steel is a highly elastic material. You can apply a huge load to it. It will bend. It will bend because of the load that's applied, but it will stretch, but it will return to its original shape and size as long as you don't exceed its limits. Plasticity is the ability of a material to withstand permanent deformation. So when you go past the material's elastic limits, it starts to deform permanently. Now, if you're able to deform it without failure over a huge or a large distance, it's known as being a plastic material. Most metals possess more plasticity when they are hot than when they are cold. So plasticity is basically you can, and we know with cold working, for instance, you can beat out a material like copper into a thin sheet, but as you work it, it gets harder and harder, and eventually, because it's you're cold working it, it will rupture. Okay, unless you anneal it. So these are all the processes we were talking about in the last bit of work that we did when we're talking about heat treatment. And then we can go on further through this video and we get to another couple of material qualities. Ductility, the capacity of a material to undergo a deformation under tension. Now it says there without rupture, which is another thing altogether. It's a rupture. So basically you're pulling it. So imagine you've got a piece of plasticine and you've grabbed it and you're pulling it apart. Pulling it into a wire. Think about pulling something out into a wire from a mass. And so it's a little bit like malleability, really. Very similar, but malleability is beating into a sheet. Ductility is pulling into a wire without rupturing it. Very closely related to the notion of plasticity. But something can be plastic at times and maybe not very ductile. And an example of that comes to mind is lead. You can beat lead into a very thin sheet, but it doesn't pull into a wire very easily. So there is differences between plasticity and ductility, but also similarities. Brittleness. A substance is brittle if it can't bear much of a shock. So the property of fracturing of a material without much shock or without deformation is called brittleness. A material will be brittle in nature if its percentage of elongation is less than 5%. So if you can't pull it out more than 5% of its length, it's deemed to be brittle. And we know that certain types of glass are brittle. They won't absorb much of a shock, which is why you've got heat treatment processes in glass and other processes like the Gorilla Glass process, which is, as we know, an ion transfer process. All of those things to try and reduce the brittleness of the actual material. And then we have, what else do we have in here? Malleability. So it says here the capacity of material to withstand compression without rupture. It can also be the ability of a material to be beaten into a sheet. Okay, so malleability, like I said, lead is malleable, but it's not ductile. But things like copper is malleable and ductile. And is there any other? And that's all the qualities. So just go back over this video and make sure you know the difference between toughness, strength, and hardness, because you can quite often confuse all those three and think that, that they're the same thing. They are not. They're very different. So make sure you've got those material qualities, a good understanding of them, because that will be helpful later on in the course. Thank you.